Good day everyone. So this one of the many tutorials. In this tutorial we'll just briefly talk about the CPU. So the CPU is the main head of the whole system. It is the central processing unit that it is at the center of everything we've been talking about: the UART, the timer, the IO ports, and the rest. So this is just briefly what the CPU subcircuit looks like. So remember, we've been talking about this is the CPU data, and this is the address, is the read write, and the VMA valid memory address. So the input, it takes just the data in input. This one's are the timer, then this is the clock and the reset as input. So the full circuit looks something like this. This is the whole design, what the whole system looks like. Remember to check out the Vero code, because that's where we got this circuit from. So we've talked about the IO port, the mini UART, we've talked about the RAM, we've talked about the timer, we've talked about the control unit, then we're going to talk about the CPU. So the boot ROM is just a ROM. It doesn't do much. It has a fixed data in it, so that's why they call it a ROM, read-only memory. It has a fixed data in it. Though I will talk about the data in it actually in another tutorial, but for this tutorial we'll be talking about the CPU. So but I'll break it down because the CPU contains a lot. So let's go in and see what the CPU looks like. So this CPU that looks small here, now this is what it looks like within it. Remember I said earlier that it contains of the ALU and the registers. So this is it here. This is the ALU here. It is the same with this one. I'll just show you the difference. Then these are the flags. The flags, you talk about the negative flag, the zero flag, the carry flag, and the rest. Now these are the registers, where the whole registers of the CPU are. This is like the main container of the CPU, the major part of the CPU. I'll be talking about these registers in its own separate unit, but in this tutorial let me just go straight and talk about the ALU. Then another tutorial will discuss about the flag, then before we now talk about the registers. So let's first of all see what the ALU was in the ALU. So this is how the ALU looks like. Now during the operation, the ALU is going to perform one particular operation per phase, whether it's adding, whether it's subtracting, multiplying, deleting, and it does this through the help of the signal that controls the ALU is the ALU control. The ALU control signal choose what exactly the ALU does. So these are the different operations of the ALU, and it's the job of this control to choose it using this demultiplexer here. So demultiplexer has a on signal. This one here is like a positive signal. So depending on the value, I think we should know what demultiplexer works, how it works. So I won't be explaining that. So depending on the value, just as you can see now, the value is 000. That's why this one is on. So let me turn it on. So depending on the value, so if I make it to be, just watch closely and see how they change. If I make it 1, it gets another operation, and so on and so forth. Gets another operation, this gets another operation, that. So it takes it sequentially 0, 1, 2, 3, 4, and so on. So I will briefly I won't be explaining it here, but just know that these are the different operations the ALU performs. Then I will explain them shortly so you see what they do. So this particular circuit here, this is it here. So whenever that ALU control signal comes here, the ALU turns on either of all these are the circuit I just showed you, which is this one, sorry, this circuit we just saw here now, this is it here on the CPU top. This is it here. We have incorporated it on the CPU. Now that LDO control signal goes in here, and these are all the functions the LDO can perform. So one of them is going to be on at a particular instant of time, depending on the value of this LDO control. So one of them is going to turn on, and whenever it turns on, all of them, they are mapped to this LDO circuit. We'll discuss this one is off and the flag is off. Just concentrate on the two I'm talking about. So all those LDO signal, they are mapped here. They are the same thing with this one here. So what this circuit does, this one which I just showed, the LDO map, is to turn on one of these LDO signals in this LDO here. Now let me open it, the LDO itself, so you see what's inside. And this is it here. This is where the LDO does this calculation and the plus and minus. So that initial circuit, all the outputs, all those operations are mapped to each of them here. So whenever any of them is turned on with the LDO control, it comes here and selects it. So anyone that is being selected, the multiplexer here turns on and the operation is being selected here. Now let me explain further. This is the LDO output of the LDO. It's different from the LDO control. The LDO control selects what function the LDO performs. Then the LDO has two registers, the LDO right and the LDO left. These are the two registers LDO used to perform, where it gets its data from. Then you have this carry. This is the carry bit. Now I'll just describe what they all do. So assuming in this circuit, the LDO map, this one, all these different operations here that are being selected by the LDO are likewise here. You map them to all these operations here. So example, the LDO add is here and is also there. So whenever I turn the LDO add in the first circuit, it turns this one on. So when you go to the code, that's what it does. So let's just go through them one after the other. Now the LDO clear, which is this first one here. This LDO clear, I've just selected it. Now whenever it's on, let's see the operation that comes on. So this is what happens. It clears it sets the LDO output to 0. It sets the LDO output to 0. So let's take for instance, let me give an output, a different value at the output of the LDO. I given different values. So now I select LDO add. So when I turned on the LDO add, it added the value of these two registers here. Now let me clear them so you see what happens whenever I clear them. I deselect the LDO add, then I select the LDO clear. You can see. So the LDO clear sets the LDO output to 0. So this is the value. So after the LDO clear, you have the LDO load. This particular one loads the value of the LDO right. It loads this value to the LDO output. So that's why I call it LDO load. You have this one store. Let me turn this one off. You have the LDO store. So it actually loads the value of the LDO left. So the first one loads LDO right, the store loads LDO left. Then you have the LDO complement. Let's see. So it negates, it gets the not value of the input to the LDO left. Then you have the negate. The difference between negate and complement is that this is what the complement do. It gets the inverse, then this other one does 0 minus the value. So it's like getting the 2's complement, negative 2's complement of the value, while the other one gets the 1's complement. Then you have also the next one, the decrement. You add 1 to it. Increment, subtract with carry. So this is the difference. This one is just the normal subtract. Subtract with carry means subtract with carry means subtract, after the subtraction you subtract the carry bit also. That is more like a full subtraction when you borrow a bit. So you subtract that 2, and this rotate left, left shift right, and the rest is add, and the add with carry. So this is the setting of the LU here. So whenever any of them is turned on, they turn on the particular multiplexer, and the multiplexer selects the particular action there and sets it as the LU output. I have actually made, and during the tutorial you will see where I listed all of them. This is it here. So here you can find all of them. So whenever it's 0, you get LU add, and this is what it does. You get all the LU control signal, all of them are here. Now this is what each of them do depending on the value of the LU control signal. You get a particular, then this is what they do, all of them. There are a lot of them. So I group them. They have conditionally what they do. You have the register memory action. So when you go to the tutorial you understand it. But this is the concept. This is the concept, what it looks like. The Velo code is there too to complement the understanding. So in another tutorial I'll be talking about the flag. Then the last one I'll be talking about the registers. So these are the 3 major parts of the CPU we'll be discussing before now talk about the boot run, and then the full circuit, how it works fully. Then I think that will be the end of how the 6805 computer works. Thank you, and subscribe to my channel.